Hello friends, this is Vishal Patel, and in this video we are going to look at the very basic and very simple SIP call flow. Also we are going to look at what is SIP transaction, what is SIP dialog, what is the difference between buy and cancel request, and many more things. First of all, thank you for a wonderful response on my first video, SIP registration and authentication process. I got a number of motivational comments on this video, and yes, this really motivates me to create this video and many more videos on this subject. I have given name diving deep into the SIP to this video, and yes, this is series, so this is part 1 of this video. So why to wait? Let's dive. First of all, we are going to understand the basic call flow as per the RFC 3261. RFC 3261 is a standard SIP RFC. So what we will do is we will open the RFC 3261 in Google, and we are going to open the website of the RFC 3261. So it's a RFC. Here we will find the basic call flow. Yes, here it is. This is a very basic SIP call flow. Where it is? Yes. In this call flow, there are two subphones. One is the Alice and other is the Bob. In between two subphones, there are two intermediate proxy. One is the Atlanta and other is the dialogs. So this is very basic call flow. We are going to understand this call flow using practical. Here they have used two intermediate proxy. One is the Atlanta and other is the dialogs. But for our experiment, we are going to use only single SIP proxy. And as a SIP proxy, we are going to use a well-known SIP proxy server, opensips. So again, we will go to our PPT. Yes, assumption is user is able to install opensips, and yes, you will find a tons of tutorial to install opensips on the net. Other assumption is user have to have a very basic knowledge of the protocol, of the session initiation protocol. Basic knowledge means user have to know what is SIP method and what are the SIP responses, what is the basic call flow of the SIP. Okay, so this is the assumption, and here is our experiment setup. We have a SIP proxy server opensips on the IP address 1.100, and we are going to create two extensions, 1001 and 1002, and we will register these two extensions on this two different IP address. One is on 1.103 and other is on 1.103. Okay, so let's start with the experiment. What we will do is first of all, we will create two extensions. One is the 1001 and other is the 1002 using the opensips CTL utility. So opensips CTL add 1001, username and password is 1001. I have already created, so it will give me output that user 1001 is already exist. Same way you have to create 1002. So 1002 and password is also 1002, which will give me that it's already exist. Okay, suppose some user which are not already exist, we will create, for example, suppose 4005 and password is also 4005. okay, add, yes. Now it will give me that new user 4005 is added. Now what we will do is, again I will open the PPT, and yes, this is our basic call flow. What we will do is, we will register these two extensions on two different machines. I will register 1001 on my Windows laptop and 1002 on my Android phone. What we will do is, we will start packet capture at opensips, and also we will start the packet capture at our Windows machine, means on the 1001. Okay, and then we will call from 1001 to 1002, and we will find this call flow. Okay, so let's start. I have added the two user 1001 and 1002. Now my other machine is Windows machine. I will take the VNC viewer of that machine. IP address is 1.103a, and I will add the password. This is my Windows machine. Okay, so what I have done is, I will register 1001, and my opensips IP address is 1.100. I have given the credentials here. Okay, so what we will do is, we will register this extension, and yes, now it is registered. We will check the registration status of the extension using the opensips CTL monitor. So here it shows that one user is registered. Okay, means I have registered 1001. If I unregister it, it will show me that 0 user is registered. Again we will register it, and now it shows 1 is registered. Okay, so our 1001 extension is registered on my Windows machine. Now what we will do is, we will register another extension 1002 on my Android phone. So I will open the Android phone, which you are not able to see. I'll open the Joyper, and I will register the extension 1002. I have registered it, and yes, now it shows 2 extension is registered. Again we can check the status of the extension using opensips CTL UL show 1001. So here it is showing that 1001 is registered on the IP address 1.103, and 1002 is registered on the IP address 1.102. Okay, so this is as per our flow. 1001 is on 103 and 1002 is on 102. Now what we will do is, we will start the packet capture at opensips and at 1001. Okay, we will start packet capture at 2 places. So I will start packet capture on my opensips, I will capture the interface ETH0 and start. So I have started the packet capture. Also I will start the packet capture at Windows machine. So I have opened the capture, and I will start on wireless interface. So here it is starting. Mostly we are interested in only SIP packet. Okay, so now what we will do is, We will call from 1001 extension to 1002. At both places we have started the packet capture, and now we will call 1002. So now Android is ringing. Now what I will do is I will accept the call. Accepted the call, and I will cut it from the one only. So I have hang up the call. Okay, yes, we got a number of packets. Also on the proxy we also got a number of packets. Okay, now what we will do is we will analyze this flow. This packet capture is at our proxy. So again I will open the flow. What 1001 has done is 1001 has sent an invite request to the proxy server, and proxy server immediately gives 100 trying to the phone. Why it is giving 100 trying immediately? You have to give the answer in the comment section, and yes, I will explain it in the next video. Okay, why it is giving 100 trying immediately after the invite request? You have to give the answer of this question. Okay, so proxy will give the 100 trying, and proxy forwards the invite to the shop phone 1002, and 1002 will immediately give 100 trying and ringing message, and now proxy forwards the ringing message to the 1001. When the 1001 gets the 180 ringing, it generates the ringing tone, that is turr turr. When it gets the 180 ringing, it generates that tone, and now 1002 accept the call, it will give the 200 OK message. So 1001 sends one invite, and for the means that is the request. Invite is a request, means 1001 sends one request and get the three responses: 100 trying, 180 ringing, and 200 OK. And this all four messages, which is called the SIP basic call setup messages, pass through the proxy server. Yes, all four messages are passed through the proxy server. Okay, so one request and the three response, this constitutes one SIP transaction, and for one SIP transaction, SIP message has to follow the same path. That means if my invite goes through the proxy servers, then all the messages has to follow the same path. Means my invite goes to the proxy server, now all the responses has to pass through this proxy, they can't bypass the proxy. Okay, now once the call is accepted by the 1002, the other message, that is the acknowledgement, that is the media starting indication, means now we start talking, that is the indication of that. Acknowledgement is that for that purpose. So that is directly 1001 directly sends acknowledgement to the 1002, means it bypassed the proxy. The packet is not going to through the proxy, it directly goes through the directly goes to the 1002. Okay, why? We will find the answer in the flow. Again we will check the practical flow which we have captured. So we have captured the flow. Okay, so now what we will do is we will analyze this flow using this telephony and VoIP calls. We have made one calls. Okay, so to find the packet of that call flow, means we have call from 1001 to the 1002. To find the first of all we stop this. To find the packets in this flow what we will do is we will prepare a filter. So when you prepare a filter, here it shows the packet number which are related to these calls, and we will apply this. So here we get the packet. Okay, again you can check the flow here. So this is the exact flow which we have shown in the PPT. So 103 sends the invite packet, and immediately proxy will give the 100 trying, and it forwards the invite to the 1002, and it will give me the ringing message, and after that conversation starts, and we can't see acknowledgement, we can't see the buy message also. Why? We will see. So on the proxy part, we got only these 4 packets, 1 request and 3 reply. We don't get this acknowledgement, so that's why we have started the packet capture on 1001 also. So we will check the packet of the 1001. So here it is. Same way we will find the call flow, voice calls. Yes, also we will stop the capture. Yes, here it is, the call flow. We will find the call flow. Yes, this is the exact call flow which we have shown in the PPT. So one invite, proxy will give the 3 responses. This request and these 3 responses becomes the one transaction. Okay, we will see in the packet. Now after accepting the 200, okay, acknowledgement is directly sending to the 102, means it bypassed the proxy server. That's why we can't see this packet on the proxy packet capture. Okay, and once we have talked, and now 1001 cuts the call, hang ups the call, it sends the buy request directly to the 102, and 102 sends the 200. Okay, so this is the very basic call flow. Okay, so what we will do is we will analyze some part here. We'll close this. Okay, and we will analyze the packet in depth. Okay, so what we will do is, here it's an invite packet. So how to identify the transaction, that I will show you. I have opened the invite packet and I will go into the message header. So message header contains the via header. So transaction is identified by the branch parameter in the via header. Okay, so where is the branch parameter? This is the branch parameter. So if you apply the filter, means where is the branch, this branch parameter, and you will apply the filter, you will get, yes, 1 request and this responses. Here this proxy sends 2 times 200. Okay, okay, means 1 invite and these 3 responses constitutes 1 SIP transaction. Okay, again I will find the SIP packet only. Number of packets we have captured, that's why it takes the time. Now acknowledgement itself is a different transaction for this purpose. And now buy. So if you open the packet buy and you search this branch parameter, and you apply the filter on this branch parameter, you will find only two packet. One is the buy and one is the 200. Okay, yes, here we got, means from 1001 to the 1002 buy request is sent and 1002 response 200. Okay, so this is another transaction. So as per our flow, from this invite to 200 okay is one transaction, this is other transaction, acknowledgement itself, and buy is another transaction. So what is transaction? One request and the replies for that request constitutes one transaction, and the total call flow from this invite to this 200 okay is dialog. Means dialog has multiple transaction, correct? Now the question is, why acknowledgement is sent directly without giving intimation to the proxy server? Because again I will open the flow and I will open the flow in the Windows machine. Again we will find the SIP. Yes, here it is. So up to this its proxy is there, means proxy IP is 1.100. 1.100 sends the 200 OK message to the phone. Now 1001 sends one acknowledgement directly, because in this transaction my friend 1001 learns the direct IP address of the 1002 from the contact header. Means here is the contact header, here it shows that, means proxy server sends the 200 OK to 103, and here it is showing that 1002 can be directly contacted on this IP 192.168.1.102. So what my intelligent friend 1001 has done is, it directly sends the packet acknowledgement to 102, because now he knows where is 1002. That's why it directly sends packet and it bypass the proxy. Now suppose proxy wants to be into the path for this packet also, then proxy have to do something for this. And what proxy have to do? If proxy wants that all the signaling messages is passed through the proxy, means all the message has to pass through the proxy, buy also, acknowledgement also, and invite also, then proxy has to do something different. What proxy has to do? For that purpose you have to give me the answer in the comment section. Okay, so this is our very basic call flow. Okay, again we will open our PPT. So we have understand this basic call flow. We haven't understand the each and every headers in the SIP messages. We will understand that part also, but we will do it in the different videos, because it will take time to understand all the headers. Now we just start with the basic call flow, means what is happening when you call from one extension to other extension. Okay, so we try to understand that part only in this video. And what is the SIP transaction and what is the SIP dialog? So what we have learned is, SIP transaction is a one SIP request, and the response for that request becomes one SIP transaction. Okay, what is SIP dialog? The total end-to-end call flow is a SIP dialog. Now again, one part is remaining, that is for every request, SIP request, it generates one C sequence ID that remains same for the transaction. Means my phone 1001 sends the invite to this, so we will check the C sequence header. The ID is 1, C sequence ID is 1, and it will remain 1 for the transaction. Means if you check this, it is 1. If you check this also, it is 1. 180 ringing, it is 1. Means for every packet which are in the same transaction, the C sequence ID is same. Also for the acknowledgement and cancel also, this remains same, that is written in the RFC. Okay, so for this acknowledgement also, means for this acknowledgement also, the C sequence ID remains same. It is different transaction, but for this acknowledgement and the cancel request, it remains same. Okay, so this acknowledgement we can see on 1001. So acknowledgement and C sequence ID, we will just minimize this, and we will find the C sequence. Yes, it is 1. It is same as the invite. Okay, now buy is a different transaction, that's why the C sequence ID incremented by 1. So for buy request it should be 2. Let's find out what it is. Yes, for buy it is 2. C sequence ID incremented by 2, and the response message also contains the same because it is for the buy, that's why C sequence ID is 2. Means for every new transaction, C sequence ID is incremented by 1. Okay, I think that's all for this video. We have understand the SIP transaction, we have understand the SIP dialog. Okay, and thank you for watching this video, and if you like this video, please write a comment and also the answer of the 2 questions in the below section. I am waiting for the answer. Also one request, means we learn from the internet. I also learn these things from the internet, and yes, we have to give it back to the internet. So please share your knowledge to the community, to us. Thank you once again for watching this video. That's all. We will meet in part 2 of the diving deep into the SIP. Thank you once again.